Hello students, welcome to the class. So in the previous class, we have discussed few questions on states of matter. Now proceeding to the next set of questions, 26th question. The temperature of a gas is raised from 27 degrees Celsius to 927 degrees Celsius. The root mean square speed of a gas. That means they have asked us RMS, root mean square velocity, right? So how do we do this root mean square velocity? We know the formula, right? So they have given us what temperature? The temperature is raised from 27 degrees Celsius. So 27 degrees Celsius, it is raised to what? It is raised to 927 degrees Celsius. Correct? Degrees Celsius has to be converted to Kelvin, add 273. So 27 plus 273 comes out to 300. 300 Kelvin, and 927 plus 273 comes out to 1200 Kelvin. So these are the two temperatures. I have converted them. Now we know that root mean square velocity or root mean square speed, that is denoted as VRMS. Correct? It is directly proportional to what? It is directly proportional to temperature. It is directly proportional to temperature. Therefore, root mean square velocity of a gas, when temperature is raised, what will happen? It will also increase. Yes. So let us see how it will increase. Therefore, I can write it as root of T2 upon T1. Yes. So what do we get? Root of 1200 upon, it is 300. So 3 ones are 3 5s are 3 ones are 3, 3 2s are 6, 9, 3 4s are 12. So it is root 400 is nothing but root 4 is nothing but 2. So how many times it has raised? It has raised 2 times. Is that right? Therefore, which is the correct option? Yes, the correct option is option D. It gets doubled. It gets doubled. Next question. The ratio among most probable velocity, mean velocity and root mean square velocity is given by. Okay. So see here, we know all the formulae of all the velocities. Okay. So let me discuss most probable velocity. Most probable velocity. I will represent it as VMP, which means most probable velocity. Okay. It is equal to what? It is equal to root of 2RT upon M. Root of 2RT upon M. This is most probable velocity. What is the formula for mean velocity? The formula for mean velocity is, it is represented as V bar. It is equal to root of 8RT upon pi M. 8RT upon pi M. Then what is the formula for root mean square velocity? Root mean square velocity. Yes, I will represent it as VRMS. Yes, so what is the formula? The formula is root of 3RT upon M. So what they have asked? They have asked me the ratio of most probable velocity, VMP, is to, they have asked the ratio of mean velocity, V bar, is to root mean square velocity. Root mean square velocity. So will be equal to what? It will be equal to root of 2RT upon M. 2RT upon M is to root of 8RT upon pi M. 8RT upon pi M is to root of 3RT upon M. 3RT upon M. Solve it out. RT upon M is common for all the factors. Therefore, it comes out to root 2 is to root 8 by pi is to root 3. Yes or no? RT by M is common. Therefore, I will cancel it out. So, I will get this answer. So, correct answer is root 2 is to root 8 by pi. 8 by pi is to root 3. This is the correct option. So, let us see which option holds true for this. That will be our correct option. Root 2 is to root 8 by pi is to root 3. So, third option D is the correct option. D is the correct option. Next question. The root mean square velocity at STP, standard temperature and pressure, for gases H2O, N2, O2 and HBr are in the order. Okay, fine. So root mean square velocity they have said. So formula for root mean square velocity is root of 3RT by M. Or I can also write it as root of 3 PV by M, because our PV is equal to RT by ideal gas equation. Yes, and we know that what is PV equal to? PV is equal to 1 by 3 M N V square. And what is V square? That is root mean square velocity. That is equal to 1 by 3 M V square. Because what is gases? They have taken 1 mole of gases. Let us consider. Okay. So M, capital M I will write V square. Is that right? M into N. Or U is V is what? This is root mean square velocity, root of 3RT by M. At STP, I know that the root mean square velocity is directly proportional to temperature and it is inversely proportional to molecular root of molecular mass. And the molecular masses I know, they have given which gases? H2, N2, O2, HBr. Correct? So root mean square velocity is inversely proportional to molecular mass. So it is inversely proportional. What is the molecular mass of hydrogen? 2. Molecular mass of nitrogen, it is 14 into 2, 28. Molecular mass of oxygen, 32. 16 2s are 32. HBr, it will become to 81. So as molecular mass increases, root mean square velocity decreases. And as molecular mass decreases, root mean square velocity increases. So which will have least value? Which is having highest molecular mass. So it is HBr is less than oxygen, which is less than nitrogen, which is less than hydrogen. Understood? So this is the correct order. Now let us see which satisfies our order. Okay, option B. So HBr, O2, N2 and H2. So this will satisfy our order. Next question. Root mean square velocity of a gas molecule is proportional to. Yes, it is proportional to. I will do it here only. See, we know that PV is equal to what? Just now we have seen 1 by 3 M capital N V square. That is root mean square velocity. Yes. So V stands for root mean square velocity. V square is equal to what? V is equal to what? V is equal to root of 3RT upon M. And V square is equal to what? It will be 3RT by M because root goes. Correct? Therefore, I can say V is equal to what? It is inversely proportional to root of M. It is inversely proportional to root of M. So which is the correct option? The correct option is inversely proportional, 1 by 2 minus root of M. Correct? So this is the correct option. Hope you understood. Understood? Okay. Next question. The energy absorbed by each molecule. The energy absorbed by each molecule A2 of a substance is 4.4 into 10 raised to minus 19 joules and bond energy per molecule is 4.0 into 10 raised to minus 19 joules. The kinetic energy of the molecule per atom will be. See what is given. There is a molecule A2, diatomic molecule. The energy absorbed by each molecule. What is the energy absorbed? The energy absorbed by each molecule, okay, by each molecule is equal to how much they have said? They have said it is equal to 4.4 into 10 raised to minus 19 joules. Correct. Further, what they have said, bond energy means what? The energy required to break the bond. So, energy required to break bond, to break the bond is how much they have said? Bond energy is 4.0 into 10 raised to minus 19 joules. Is that right? Okay. So what they have asked, the kinetic energy per molecule. So remaining energy, see, this much energy is used to break the bonds. This much energy is actually absorbed. That molecule A2, it has absorbed 4.4 into 10 raised to minus 19 joules of energy. And out of that much energy, it is using 4.0 into 10 raised to minus 19 joules to break the bond. That means, can I say remaining energy to get converted to kinetic energy. Correct? Yes. Therefore, can I write it like this? Equal to 4.4 into 10 raised to minus 19 minus 4.0 into 10 raised to minus 19. The powers of the exponents are same. So I can do the subtraction. It will be 0.4 into 10 raised to minus 19 joules per molecule. What they have asked? The kinetic energy of the molecule per atom they have asked. Correct? So a molecule is made up of, they have said molecule is A2. It is made up of two atoms, A and A. Therefore, this is per molecule. Therefore, I can say kinetic energy per atom will be what? Divided by 2. That will be 0.2 into 10 raised to minus 19 joules. Correct? Is that right? Divided by 2 because there are two atoms. It is a diatomic molecule. Or I can write it as 2 into 10 raised to minus 20 joules. Shifting the decimal point to the right, minus 1, it becomes minus 20. So, whichever option contains that will be marked out. Is that right? I hope you have understood it. So, which is the correct option? 2 into 10 raised to minus 20 joules. So, option D is the correct option. Okay. Next question. If a gas expands at constant temperature, it indicates that. What does it indicate? It is expanding at constant temperature. So options are kinetic energy of the molecules remains same. Number of the molecules of gas increases. Kinetic energy of the molecules decreases. Pressure of the gas increases. So let us see what does it indicate. So what they have said? If a gas expands at constant temperature. Okay. See, gas at constant temperature, gas expands. One thing we can understand from this, volume is increasing. Okay. At constant temperature, gas is expanding means what? The average kinetic energy of one molecule of an ideal gas. Of an ideal gas is given by E T is equal to kinetic energy upon Avogadro number. Okay. Kinetic energy for an ideal gas, it is 3/2 RT upon Na. Or I can write it as 3/2 kT, where K will be what? It is a Boltzmann constant. So K is equal to R by Na because these are both constants. So R by Na. Okay. From this expression, I can come to the conclusion that this is a constant. So ET, average kinetic energy, is directly proportional to what? It is directly proportional to temperature. So at constant temperature, what will happen to if the gas expands? If the gas expands at constant temperature, the kinetic energy of molecules, remains same. Because kinetic energy is directly proportional to temperature, and they have said at constant temperature. Is that right? So correct option is what? Kinetic energy of the molecules remains same. It remains same. Next question. Average molar kinetic energy of carbon monoxide and nitrogen at same temperature is. The average molar kinetic energy of carbon monoxide and N2 at same temperature. Just now we have seen the equation. What equation we have seen? kinetic energy is equal to 3 by 2 RT, correct? And this is for 1 mole of gas. Okay, for 1 mole of gas. As temperature are same, so they have said at same temperature. As temperature is same, kinetic energy is what? It is independent. Kinetic energy, just now we have seen, see this equation only you see, it is, there is no molecular mass here, correct? So I can say kinetic energy is independent. It is independent of what? Molecular mass. Because kinetic energy depends only on temperature. And temperature is same. So kinetic energy is independent of molecular mass. Whether you take carbon monoxide, nitrogen, you take any gas, it is independent of the molecular mass. Therefore, we can say kinetic energy of CO is equal to kinetic energy of N2. Or if I consider carbon monoxide as gas 1 and nitrogen as gas 2, we can write it as kinetic energy of gas 1 is equal to kinetic energy of gas 2. Understood? So from this equation only we come to the conclusion. What we understand? Kinetic energy, see 3 by 2 R is a constant. So remove the constant, it will come to kinetic energy is directly proportional to T. Understanding? And it is dependent only on temperature. And they are saying temperature is same. And kinetic energy, there is no point of molecular mass. See, there is no point of molecular mass. Therefore, since it is independent of molecular mass, it is same for both the gases. It is same for both the gases. Is that right? Okay. Next question. The average kinetic energy of an ideal gas per molecule in SI units at 25 degrees Celsius will be. Okay, the question is, they have asked average kinetic energy. Temperature they have given out to what? They have given temperature as 25 degrees Celsius. 25. Convert it to Kelvin, it comes to 25 plus 273. It is 298 Kelvin. Okay, temperature. So they have said average kinetic energy. Kinetic energy of molecule. So I have average kinetic energy per molecule, I can say. Per molecule is equal to what? It is 3 RT by Na. 3 RT by Na. So 3 into, what is the value of R? 8.314. Then into temperature is 298 divided by Avogadro number 6.0. So 3 RT, 3 by 2 RT Na. Yes, so 2 into 6.022 into 10 raised to 23. Solve it out. When you solve it out, you'll get the answer 6.17 into 10 raised to minus 21 joules. 6.17 into 10 raised to minus 21 joules. Yes. So let us see which option holds good for this. So the option is 6.17 into 10 raised to minus 21 joules. So it is option D, which is correct. Option D, which is correct. Okay, fine. Next question. At STP, standard temperature and pressure, 0.50 moles of H2 gas and 1.0 moles of helium gas. What do we understand from this? Okay. Let us understand here. See, at STP, 0.50 moles of H2 and 1.0 moles of HE gas. So they have taken two gases and they have given us the volumes. Yes, we know that. What is average kinetic energy? They have question on kinetic energies, right? Okay. For option A is they have equal average kinetic energies. Option B is have equal molecular speeds, occupy equal volumes, and have equal effusion rates. Okay, let us see which is correct. Average kinetic energy depends on what? Average kinetic energy depends on temperature. Is it right? Because 3 by 2 RT. Yes or no? It depends on temperature. This is constant. So I will write Ke is directly proportional to temperature. So since it depends on temperature, how much ever amount you take or whatever gas you take, it is independent of that. So it is dependent only on temperature. So can I say kinetic energies will be same? Yes. So first option itself is the right option. So what is the first option? They have equal kinetic energies. That is the correct option. They have equal kinetic energies. Is that right? Yes, because average kinetic energy, you know the formula, Ke is equal to 3 by 2 RT. Yes, okay. Next question. Internal energy for internal energy and pressure of a gas per unit volume are related to internal energy and pressure. Okay, so what is equation? See, we know this equation, right? We have seen explanation for kinetic theory of molecules. There we have seen PV is equal to what? It is equal to 1 by 3 m n v square, where v is root mean square velocity. Or I can write it as 1 by 3 m into n, mass into number of moles, as molar mass into v square. I can write it like this also. Okay, you can represent it like this. So what you do is you represent. So I will write here in this equation, it will be 2 by 3. Energy equation is what? Energy equation is 1 by 2 m v square. Substitute this. So I can write here 2 by 3 into 1 by 2 m v square. 2 by 3 into 1 by 2 m v square, and that is nothing but 2 by 3 half mv square is what? Half mv square is energy. Half mv square is energy. Yes, so PV is equal to 2 by 3 into E. So what is P related to? So if I say volume is 1 unit, I can say P is equal to 2 by 3 into E per unit volume. Per unit volume. So this is the correct relation. So what is the relation given? The relation given is P is equal to 2 by 3 into E. Option A is the correct option. Option A is the correct option. Next question. A closed flask contains water in all its 3 states, solid, liquid and vapor at 0 degrees Celsius. In this situation, the average kinetic energy of the water molecules will be. So it is present in solid, liquid and vapors at 0 degrees Celsius. So what will be the situation? Option A, the greatest in all the 3 states, the greatest in vapor state, the greatest in liquid state, the greatest in solid state. So they have asked what? Average kinetic velocity energy. Average kinetic energy means what? Kinetic energy is half mv square. It is nothing but velocity. Therefore, I can say velocity and hence average kinetic energy of water molecules is maximum where? Where kinetic energy is more. Yes, I need not say this. You already know. In case of solids, they are packed very strongly. In case of liquids, they are slowly free. Whereas in case of gases, they are very far. So if we say here, there is only vibration motion. Here they have certain motion, but it is less than gases. Here the kinetic energy of the molecules is high. Correct. Therefore, average kinetic energy means what? It is nothing but velocity only. So I can say velocity and therefore average kinetic energy of the water molecules will be greatest in what? It will be greatest in vapor state. It will be greatest in vapor state. Is that right? Because we know kinetic energy is equal to half mv square. Okay. Next question. Which is not true in case of an ideal gas? It cannot be converted into liquid. Not true. Yes, this is true. It cannot be converted into liquid. Ideal gas is a hypothetical concept. There is no interaction between the molecules. Yes, ideal gas says that there is no interaction. Kinetic molecular theory of ideal gases was given to say that there is perfectly no interaction between the gaseous molecules. There is no attraction between the molecules. That was proved to be wrong. That's the reason our real gases show the deviation from ideal behavior. Yes or no? Van der Waal had given it. All the molecules of gases move with same speed. Is it right? No. Molecules in an ideal gas, they move with different speeds. Tell me, why do they move with different speeds? Due to the collisions between the particles, their speed will change. When the molecules collide, their speed changes. So molecules of gas, all the molecules of gas move with same speed is a wrong concept. Because in ideal gases, they move with different speeds. Why do they move with different speeds? Because of the collisions between the particles Their speeds changes. At a given temperature, PV is proportional to amount of gas. Yes, that is also correct. That is also correct. So which is not true? It is option C. All the molecules of the gas move with the same speed. That is not true because they have different speeds due to the collisions between the particles. Next question. A gas at 350 Kelvin and 15 bar pressure has molar volume of 20% smaller than that for an ideal gas under the same conditions. So 20% smaller than that for an ideal gas under the same conditions. The correct option about the gas and its compressibility factor is Z stands for compressibility factor, less than 1 and repulsive forces are dominant, greater than 1 and attractive forces are dominant, greater than 1 repulsive forces are dominant, less than 1 attractive forces are dominant. Okay, let us see how we can solve this. See what they have said. They have said that 350 Kelvin temperature and 15 bar pressure. Okay. Has molar volume 20% smaller than that for an ideal gas. So volume of ideal gas, if I say, yes, it is equal to, let me say it is equal to V. Then volume of a real gas, it will be equal to what? It will be equal to 20% less. So it can I say V minus 0.2 into V? 20% less. 20 by 100, 0.2. Correct? That is equal to what? That will be equal to V common 1 minus 0.2 and that is nothing but 0.8 V. Will you get this volume? Correct? Okay. Z is equal to what? PV by nRT. So V is there on the top. Therefore, I can write volume of real gas upon volume of ideal gas. Is that right? So volume of real gas is what? 0.8 V. Upon volume of ideal gas is V. V gets cancelled. So Z is equal to what? It is 0.8. That means Z is less than 1. Yes. Why Z is less than 1? Because if you see this particular measure, observe this particular thing. I can write this equation like this also. V real is equal to 0.8 into V ideal. Getting? V of ideal. That means the attractive forces are more dominant. Yes, so only multiply by this factor, you will get the volume of real gas. We'll get the volume of real gas. Therefore, we say attractive forces are dominant. Attractive forces are dominant. Is that clear? Attractive forces are dominant. I hope this concept is understood. Just find the compressibility factor. Just find the compressibility factor. Okay. Fine. Next question. So the correct option is Z is less than 1 and attractive forces are dominant. Z is less than 1 and attractive forces are dominant. Correct? Okay. Next. A gas such as carbon monoxide would be most likely to obey ideal gas law at. Okay. It would most to obey what? Low temperatures and high pressures, high temperatures and high pressures, low temperatures and low pressures, high temperatures and low pressures. So a gas such as carbon monoxide would be most likely to obey the ideal gas. See, real gases, they show ideal behavior. And we know, forget about real gases showing ideal behavior. We know the definition of real gases. What we know? We say the definition of real gas as real gases do not obey ideal gas equation at all conditions of temperature and pressure. This is one way of representing. Or real gases obey the ideal gas equation at extremely high temperatures and low pressures, right? So carbon monoxide is a real gas. Real gases show ideal behavior at high temperatures and very low pressures. So option D is the correct option. Option D is the correct option. Is that right? Okay. Next question. Maximum deviation from ideal gas is expected from. Maximum deviation from ideal gas is expected from. When we were discussing deviation from ideal behavior, we spoke about the polarity. Yes. Where there is more polarity, there will be more attractive forces between the molecules and there will be maximum deviation. So look at the options and which is polar, you just see. Forget CH4, H2, N2. These are non-polar molecules. And the only polar molecule is NH3. So NH3 being a polar molecule, it will have more attractive forces between ammonia molecules. Therefore, it will show maximum deviation because according to our kinetic molecular theory of gases, what does it say? It says that there is no attractive forces between the molecules. Yes, and we can expect this in real gases also when the attractive forces are less. Where the attractive forces will be this, where there is non-polar molecules. So only when we're discussing about deviation of real gas from ideal behavior, we discuss that H2, N2, O2, the helium, they're all non-polar molecules. They show positive deviation. Whereas CH4, carbon dioxide, carbon monoxide, NH3, they all show negative deviation. That is, first the product of PV decreases, reaches a certain minimum point, and then it increases. Is that right? So ammonia here, in this case, maximum deviation from ideal gas is expected for ammonia, NH3. NH3 being a polar molecule, more attractive forces between the NH3 molecules. Is that right? Next question. For real gases, Van der Waals equation is written as P plus AN square by V square into V minus NB is equal to nRT, where A and B are called what? Van der Waals constants. Two sets of gases are O2, CO2, He and helium, CH4, O2 and H2. So these are the two different sets of gases they have given. The gases given in set 1 in the increasing order of B and the gases given in set 2 in the decreasing order of A are arranged below. Select the correct order from the following. Okay. So what they have said, Van der Waals equation they have considered. So Van der Waals equation is P plus AN square by V square into V minus NB is equal to nRT. This is Van der Waals equation. Okay. So Van der Waals gas constant A. Yes, this is A and B are constants. It represents what? It represents the intermolecular forces of attraction. This is actually a very beautiful question, framed very beautifully. Yeah, so many things we can understand from this question. So intermolecular force of attraction of the gaseous molecules. And Van der Waals constant B tells us what? It tells us about it represents effective size of the molecules. Effective size of the molecules. So what they have asked? The gases given in set 1 in the increasing order you want, and set 2 in the decreasing order. Set 1 in the increasing order means where intermolecular forces of attraction are less. Options given are, which are the options? Set 1, the options are O2, CO2, H2 and He. And set 2 options are CH4, O2, H2. So increasing order, first set you arrange them. So how do you arrange them? Intermolecular force of attraction in the increasing order they have said. Okay. The gases given in set 1 in increasing order of B. Yes, B means what? Effective size of the molecules. Correct? So effective size when I consider, which comes first? H2 is having least, then comes He, then comes O2, and then comes CO2. Correct? This is the correct option. Then the gases given in set 2 in the decreasing order of A. Decreasing order, that means which is having maximum intermolecular force of attraction. See, carbon, O2 is purely, O2 and H2 are purely diatomic homonuclear molecules. But CH4 is a heteronuclear molecule. So here the intermolecular attractions are more. Then comes what? O2, because bond order is less, bond order is 2, bond energy will be more. So they'll be held strongly. Then comes H2. Is that right? So which will give the correct option? That is the correct answer. So which is the correct option? H2, He, O2, CO2. So option C, CH4, O2 and H2. Yes, option C is the correct option. Option C is the correct option. Okay. Moving to the next question. Van der Waals real gas acts as an ideal gas at which conditions? Van der Waals real gas acts as an ideal gas at which conditions? Okay, real gas acts as an ideal gas. At which conditions? We know that according to Van der Waals equation, at low pressure and high temperature. At low pressure and high temperature, Van der Waals real gas acts as ideal gas and observed to obey PV is equal to nRT. Okay, PV is equal to nRT. What happens at very low pressure when the gas volume is quite large? The space occupied by the molecules themselves becomes negligible. At very low pressure, when gas volume is quite large. Yes, so pressure is very low means what? Volume will be too much. When volume is too much, the volume occupied by individual gas becomes negligible, and that is correct with kinetic theory of gases. Correct. And because the molecules are then far apart, the forces of mutual attraction also becomes less. It becomes feeble. Understanding? The real gas would satisfy the postulates of kinetic molecular theory of gases. Understanding why is it so? Because at very low pressure, volume is very large. So when volume is large for a gas, imagine the volume occupied by an individual molecule becomes very less, as said by kinetic molecular theory of gases. Correct? Second point, since the volume is very large, the molecules are very far away from each other. So when they are very far away from each other, the force of attraction will be very weak. So almost negligible, you can say. So there will be no forces of intermolecular forces of attraction. Intermolecular forces of attraction. Is that right? And that also is obeyed by kinetic molecular theory of gases. Further, as temperature increases, what will happen? The volume of the gas also increases because V is directly proportional to T. Which law? It is Charles' law. Fine. So volume of the gas increases and we can consider P plus n square A by V square term as P. And at low pressure, this is at high temperature, at low pressure, what we can say? V minus NB can be taken as V. Therefore, the equation becomes what? It becomes PV is equal to nRT. This Van der Waals equation becomes PV is equal to nRT. And that is what? Ideal gas equation. So what conditions? At very high temperature and very low pressure. Very high temperature and very low pressure. Is that right? Okay. When is deviation more in the behavior of a gas from ideal gas equation? PV is equal to nRT. When deviation is more? Opposite of this. At high temperature and low pressure, the real gas is behaving like ideal gas. So real gas is behaving like ideal gas. It is behaving like ideal gas means what? It is obeying the equation PV is equal to nRT. When a deviation is more, when it is opposite, that means the temperature should be how? It should be very low and pressure should be very high. Yes or no? At very low temperature and very high pressure, there is large deviation from ideal behavior. So at low temperature and very high pressure, the deviation of real gas from ideal behavior is maximum. It is maximum. Okay. Next question. A gas is said to behave like an ideal gas when the relation PV by T equal to constant. When do you expect a real gas to behave like an ideal gas? Same question. Okay, let me write it here. What are the conditions? At high temperature and low pressure. Yes, at high temperature and low pressure, I can say in Van der Waals equation, the effect of A by V square and B is negligible. Yes, the effect of A by V square in pressure correction and B in volume correction is negligible. Therefore, in that case, PV is equal to RT, or PV upon RT is equal to what? 1. And what is this one? 1 is nothing but compressibility factor. 1 is nothing but Z, compressibility factor. And if Z is equal to 1, the real gas shows the ideal behavior. It shows the ideal behavior. Is that right? So which is the correct option? When the temperature is low? No. When both temperature and pressure are low? No. When both temperature and pressure are high? No. When temperature is high and pressure is low. You understood why? So when temperature is high and pressure is low, the pressure correction A square by A by V square and the volume correction B become negligible. At that time, PV will be equal to RT, or I can write PV by RT is equal to 1. And what is 1? Compressibility factor, that is Z. So Z becomes equal to 1 means what? Z is equal to 1 for ideal gases. And this is possible when the temperature is high and the pressure is low. When the temperature is high and pressure is low. Next question. In van der Waals equation of state for a non-ideal gas, the term that accounts for intermolecular forces is the term that accounts for intermolecular forces. See, I have explained it when I was explaining van der Waals equation also. The van der Waals equation is correction in pressure term P plus A n square by V square into V minus NB pressure volume correction is equal to nRT, correct? If it is 1 mole, so here P plus A by V square, if I consider 1 mole, this is the equation. This equation represents what? It represents the intermolecular forces. Intermolecular forces. Yes. And V minus B represents what? It represents the correct volume. That is nothing but size correction. Correct volume means what? It tells us about the effective size. Yes. So what question is asked? The term that accounts for intermolecular forces is what? It is P plus A by V square. It is P plus A by V square. So correct option is option C. It is option C. Given van der Waals constants for ammonia NH3, hydrogen gas H2, oxygen gas O2, and carbon dioxide are respectively 4.17, 0.244, 1.36 and 3.59. Which one of the following gases is most easily liquefied? So based on van der Waals constants. Yes. See, van der Waals constants, there are A and B. As we discussed, A signifies the intermolecular force of attraction between the particles of the gas. And B signifies what? B signifies the size of the molecules. Okay. Here they have given us van der Waals constants, so and so. These are nothing but intermolecular force of attraction. So van der Waals constant A signifies the intermolecular force of attraction between the particles of the gas. Higher the value of A, easier will be the liquefaction of gases. Higher the value of A. So I'll write it here. Higher the value of A. Higher the value of A, easier will be liquefaction. Easier will be liquefaction. Yes, easier will be the liquefaction. So where the value of A is highest? It is 4.17. So 4.17 comes first. This is most easily liquefiable. Then comes 3.59. Then comes 1.36 and then comes 0.244. So 4.17 is for ammonia. So this is most easily liquefiable. 3.959 is for carbon dioxide, second most liquefiable gas. Then 1.36 is for oxygen. And last one is H2. Understanding? So higher the value of van der Waals constant A, easier will be the liquefaction of the gas. And it is correct option is option ammonia. It is A. Next question. An ideal gas obeying kinetic theory of gases cannot be liquefied. Why? Why cannot you liquefy an ideal gas which obeys kinetic theory of gases? Option A, it solidifies before becoming a liquid. Option B, forces acting between its molecules are negligible. Option C, its critical temperature is above 0 degrees. Option D, its molecules are relatively small in size. See, is it because it solidifies before becoming a liquid? No, that is not the case. Here we are discussing about liquefaction. We are not talking about sublimation. Forces acting between its molecules are negligible. Yes. Kinetic theory says a gas can only be liquefied if some forces of attraction are acting in its molecules. According to kinetic theory, an ideal gas doesn't have any forces of attraction, yes or no, in its molecules. Therefore, it cannot be liquefied. But if you want to liquefy gases, what there should be when you increase the pressure, volume decreases, we say, because the molecules will come closer. There will be forces of attraction. So we say a gas can only be liquefied if and if only there are some forces of attraction acting in its molecules. But kinetic theory says the forces of attraction between the molecules are almost zero, negligible. Yes, therefore option B says that gas cannot be liquefied according to kinetic theory of gases. Cannot be liquefied. Next question. The beans are cooked earlier in a pressure cooker. Why? Very nice question. Why in a pressure cooker the beans you take, or you take rice, it gets cooked faster in a pressure cooker rather than keeping it boiling outside open? What is the reason? What happens in pressure? Why it is called pressure cooker? Because pressure is more there. So more is the pressure, greater will be what? Greater will be the boiling point. Yes or no? So if the pressure is more, the boiling point will be more. Understanding? So what is the correct option here? Boiling point increases with increasing the pressure. Boiling point increases with increasing the pressure. Therefore, the beans are cooked earlier in a pressure cooker. Or one more option, example I can give you. If you go to higher altitudes, you will need more boiling point of water will be more there. That means water will not boil as boil at 100 degrees Celsius. The reason is at higher altitudes, pressure is less. Yes, water will boil quickly there. Boiling point decreases with the decrease in pressure. Understanding? So beans are cooked earlier in a pressure cooker, or rice gets cooked earlier in a pressure cooker because boiling point increases with increase in pressure. With increase in pressure. Yes. Next question. A compound exists in the gaseous state both as monomer and dimer A2. The molecular weight of the monomer is 48. In an experiment, 96 grams of the compound was confined in vessel of 33.6 liter and heated to 273 degrees Celsius. Calculate the pressure developed if the compound exists as a dimer to the extent of 50% by weight under the conditions. Very beautiful question. See, a compound exists in gaseous state both as monomer and dimer. Monomer means what? Single molecule. Dimer means combined. Dimer means combined. Molecular weight of monomer is what? 48. Then what will be the molecular weight of dimer? 48 into 2, that is 96. In an experiment, 96 grams of the compound was confined. So 96 grams of the compound was confined in a vessel of, what was the volume of the vessel given? 33.6 liters. And it is heated to 273 degrees Celsius. Calculate the pressure developed if compound exists as what? Exists as dimer only. Okay, to the extent of 50% by weight under the conditions. Okay, how do we solve it? See, what is given? Weight of the compound is given. Weight of a compound is how much? 96 grams they have said. And they have said the compound exists as monomer and dimer. And in the question, what the question they have said? The question what they have said is 50% by weight as a dimer they have said. It exists both as monomer and dimer. In the beginning they have said 50% by weight as a dimer. That means what is compound existing as? I can say the compound exists as, it exists as 50% monomer monomer and 50% dimer, correct? 50% dimer. Is that right? Okay. Now we will calculate moles of monomer. Number of moles of monomer is equal to what? What is the given mass of monomer? 48 grams they have said, divided by, that is the amount 48. So it is equal to 1. Number of moles of dimer. So amount is 48 divided by, dimer means into 2. So molecular mass is 96. So 1 by 2 is what? 0.5. So this is number of moles of monomer. This is number of moles of dimer. What they have asked us to calculate? Pressure. P is equal to. So they have said for monomer you have to go into so total, how much is the get? It is 1.5 into total number of moles, right? 1.5 into value of R 0.0821 into 273 degrees Celsius they have said. So 273 plus 273. I'll write it like this, 273 plus 273. Okay. The whole divided by how much volume? 33.6 liters. So since it is given in liters, I took the value of R as 0.0821. Okay. So solve it out. 1.5 into 0.0821, 273 plus 273 is 546 divided by 336. It comes out to 2 atmosphere. It comes out to 2 atmosphere. So which is the correct option? Correct option is 2 atmosphere. Option C is the correct option. Is that right? Okay. Next question. The next question is, by what factor does average velocity of a gaseous molecule increases when the temperature in Kelvin is doubled? So by what factor average velocity? What do we mean by average velocity? Such question, one of the question we had seen. So average velocity is equal to what? Root of 8 RT by M. Correct? Average velocity. And we know that velocity is directly proportional to temperature here. Or I'll say root of temperature. Correct? So V2 by V1. They have said temperature is doubled. So I can write 2T upon T. Correct? 2T upon T. Solve it out. You will get 1 root 2. Root 2 value is what? Root 2 value is 1.41. It is 1.41. So what is the correct option? We have solved this question, I guess. It is 1.41. It is 1.41. Next question. The molecular velocities of two gases. The molecular velocities of two gases at same temperatures U1 and U2 and their masses M1 and M2 respectively. Which of the following expressions are correct? Okay. Molecular velocities they have given. Fine. So here, molecular velocity, root means square velocity. So they have mentioned it as U. So I will write it as U. U is equal to, it is inversely proportional to molecular masses. So root of 1 by M1 I can say. Similarly, inversely proportional. U2 will be inversely proportional to root of 1 by M2. Is that right? So take square of, I will take here as U1 upon U2 will be equal to what? Root of M2 upon M1. M2 upon M1. Or take U1 square upon U2 square. U1 upon U2 the whole square, or U1 square upon U2 square. Squaring this side, root comes out. M2 upon M1. M2 upon M1. So I will take it in this format. U1 square into M1 is equal to U2 square into M2. Is this option present? So U1 square upon, yes, option D. Yes, D is the correct option. U1 square upon into M1 is equal to U2 square upon M2. So option D is the correct option. Next question. Let the most probable velocity of hydrogen molecules at temperature T degrees Celsius be V naught. When the temperature is raised to 2T plus 273 degrees Celsius, the new RMS velocity, suppose all the molecules dissociate into atoms at the latter temperature. Okay. Root means square velocity, RMS. Fine. Okay. So root means square velocity. So I will represent it as V naught, they have said. They have said 2RT upon M. Yes, that is equal to root of R into 273 plus T, as they have mentioned. Okay. So VRMS is equal to root of 3 by 2 RT. So what is the value of T? So here I will write it as 2T plus 273 plus 273 into R by 1. R by 1. That is equal to what? Solve it out, you will get 6T plus 273 into R. That is nothing but root of 6 V naught. Root of 6 V naught, because V naught is what? RT into 273 R. Yes. So which is the correct option? Correct option is option B. Root of 6 into V naught. Root of 6 into V naught. That is the correct option. Next question. The correct value of gas constant R is close to. Correct value gas constant R is close to. So 0.821 is common. So where we have proper option, liter atmosphere per Kelvin per mole. Yes, option B is the correct option. Option B is the correct option. Next question. If 10 raised to minus 4 dm cube of water is introduced into 1 dm cube flask at 300 Kelvin, how many moles of water are in the vapor phase when equilibrium is established? Excellent question, right? Vapor pressure of water is given 3170 pascals and universal gas constant is given. See, so beautiful question it is. So much water is introduced in a given volume. So we know that PV is equal to nRT. PV is equal to nRT. Okay. Or N is equal to what? PV by RT. PV by RT. What is the pressure they have given? 3170 into 10 raised to minus 3. Divided by R value 8.314 into temperature is 300 Kelvin. Right? Solve it out. What answer you get? You will get the answer 1.27 into 10 raised to minus 3. 1.27 into 10 raised to minus 3. So correct option is option D. Simply PV is equal to nRT you put. You will see how many moles of water are established into the, you'll get number of moles. N is equal to PV by RT. N is equal to PV by RT. Okay. A bubble of air is underwater at temperature 15 degrees Celsius and pressure 1.5 bar. If bubble rises to the surface where the temperature is 25 degrees Celsius and pressure is 1 bar, what will happen? Yes, we have discussed this question. The answer was what we have seen. The volume of the bubble becomes greater by a factor of 1.6. Yes, we have seen this question, right? The volume becomes greater by a factor of 1.6. This question is discussed. Okay. Then next question. Next question is, air at sea level is dense. This is a practical application of. See how beautifully the application is given for a law. So according to Boyle's law, what we know? Density we are discussing. So P is inversely proportional to volume. Sorry, inversely proportional to volume. Yes. So according to Boyle's law, we have seen that density is directly proportional to pressure. Density is directly proportional to pressure. Because we know the equation D is equal to PM upon RT. PM upon RT. This is equation we have seen. So air at sea level, what happens at sea level? Pressure is more. So at sea level, pressure is more. So as pressure is more, density will be what? Density also will be more. Yes or no? Density also will be more. So what is this? This is the practical application of Boyle's law. This is the practical application of Boyle's law. Is that right? Practical application of Boyle's law. The correct order of viscosity, the correct order of viscosity of the following liquids. So viscosity question, which is the correct order? So what is the correct order? Where viscosity will be more. The correct order is, it is option C. Dimethyl ether is least viscous because it is more volatile. Then comes methyl alcohol, then comes water, and then comes glycerol, because viscosity is inversely proportional to volatility. And this is most volatile, so it is least viscous. Yes, then comes methyl alcohol, then comes water, then comes glycerol. Then comes glycerol. Next question. The molecular velocity of any gas. The molecular velocity of any gas is equal to what? So we have seen the velocities of different terms. Yes. Do you remember the velocities? Most probable velocity is equal to root of 2RT upon m. Average velocity V bar is equal to root of 8RT upon pi m. And then RMS velocity, root mean square velocity, is equal to root of 3RT upon m. So we know that most velocities, yes, molecular velocities is directly proportional to root of temperature. It is directly proportional to the root of temperature. So which is the correct option? The correct option is directly proportional to the square root of temperature. Yes. Next question. Which of the following volume temperature plots represent behavior of 1 mole? Represents the behavior of 1 mole of ideal gas at 1 atmosphere pressure. So which one represents at 1 atmosphere pressure? So volume, and option A is so, option B, option C, option D. So which is the correct option? We know that V1 upon T1 is equal to V2 upon T2 at constant pressure. So they have given us 22.4 liters upon 273 is equal to V2 upon 373. Yes. Solve it out. You will get V2. V2 will be equal to what? 22.4 into 373 upon 270. When you solve it out, you will get the answer 30.6 liters. So which question option is correct? It is option C, 30.6 liters. Yes, they have given it in the form of graph. That's it, instead of giving the answer. So that is the correct option. Yes. Next question. Match the following. Boyle's law. It is what? Is P inversely proportional to 1 by V. So Boyle's law, A is nothing but V, option. Then B, Charles' law says what? Charles' law says volume is directly proportional to temperature at constant temperature, at constant pressure and number of moles. So B option is correct for fourth one. Then Dalton's law of partial pressure says that the total pressure is equal to sum of the partial pressures of the individual gases. So it is equal to 2. Then option D, Avogadro's law says volume is directly proportional to N at constant temperature and pressure. So D is option 1. So which one holds true? It is option A. Yes, simple question. So this covers almost all the concepts of states of matter. I hope you have followed with all the questions. Do practice a few more questions for making your concepts clear. Yes, hope you have understood all of them. Thank you.